Hey guys, this is Tamogno and welcome to Being Engineers. Today we are going to talk about LED and photodiode. So let's begin. LED is a two-terminal PN junction diode that has a cathode and anode. If you supply some voltage across its terminal, then the current will flow through the LED. Everyone knows that. Now photodiode is a two-terminal PN junction diode as well, but the working principle is completely different. Now let us come back to LED. As I told earlier, LED is a PN junction diode. In P-type, the majority carrier is hole, and in N-type, it is electron. Now you connect a 3-volt battery across the terminals. So the opposite polarity of the battery will attract the oppositely charged electrons and holes. Electron will move on the positive side and the holes to the negative side. So a current will start flowing through the diode in this orientation and the electron flow in this orientation, because we know that the current flow direction is opposite to the electron flow direction. Now if we concentrate in this junction area, then it will look like this. So this is the junction. These are the electrons of N-type and these are the holes in the P-type. Now as soon as I give some potential difference across the cathode and anode, the holes will try to go in this direction and the electrons will try to go in the opposite direction. So eventually they will recombine. You know that electron stays at a higher energy state than that of a hole. So the electron will be losing some energy before recombining with a hole. This very energy that the electron will be losing will come out of the diode as a photon. And the amount of photon and the energy that will come out of the diode will determine the color and strength of that light. So this is how an LED works. Here you can see a 3-volt coin cell and a 5mm blue LED. If we connect the anode and cathode properly to the battery, then the LED will start glowing. Now I will put this same LED in the breadboard and connect my multimeter probe across the terminal. So this is the multimeter and the regulator is set to measure a voltage of maximum 2 volt. Here I have a mobile in which the flash is quite strong. So I will hold this flash on this LED. As soon as I take the light closer to the LED, you can see some voltage reading is coming in the multimeter. The voltage is very less, not even 1 volt, but still it is produced across the terminals. If I take the flash away from the LED, then the reading is coming to be 0. So we get a maximum reading of 0.6 volt that is quite sufficient in terms of electronics. So in this video we learned that a simple LED can also be used as a photodiode. And this same logic can also be applied in phototransistors. And this we will be covering in another video. Thanks for watching. Until then, bye. Yeah.